multiple handling multiple sources. So how to handle multiple sources is what we're learning now. Okay, how to handle multiple current sources or multiple voltage sources if they are there in a circuit. Fine. Everybody look at this. The first thing that we're learning is uh, multiple current sources. Everybody just copy this. Multiple current sources. Copy down this now. Copy down what I'm doing. See here. Copy the circuit diagram. You have a current source in parallel with the resistor. Again, you have another current source. Sorry, another current source I should have written. Okay, you have another current source. Fine. You have yet another current source. Why we are talking about so many current sources? Because we're talking about what happens if we have so many different current sources in the same circuit connected in parallel, mind you. So there are two terminals like this, A and B, suppose. Okay. There is a circuit like this, wherein this is 10 ohms, let's say. This is 10 ohms. Fine. This is 2 amps. Fine. This is 3 amps. Fine. And this is what? Say 5 amps. No, let's say let's make this as this 5 amps. Yeah, let it be. Yeah. Now you have, everybody listen here. Now you have 3 current sources and a resistor, all connected in parallel. They're all connected in parallel. Okay. What we can do here, if they're all connected in parallel, see, we can, if there are current sources connected in parallel like this, we can reduce these current sources to one current source. How? Now see here, this 3 ampere and 2 ampere, you see this, right? So 2 ampere is going upwards, 3 ampere is coming downwards, and 5 ampere is going upwards. Everybody understand that? Okay. Now you can add the current sources wherein the currents are flowing in the same direction. That means this 5 amps and 2 amps can be added. Everybody understand that? See here, the 5 amps and 2 amps can be added because they are in the same direction. So what you can do is this 5 amps, okay, this 2 amps and 5 amps can be added. Okay, so you'll be left with just 2 current sources compared to earlier case. And what is this? This is 2 amperes plus 5 amperes. Since both are going upwards, we are adding them up. Okay, and what is there is 3 amperes we have taken as it is. Okay, and this is 10 ohms. Everybody understand that? Okay, so these are terminals AV. Now 7 amperes is going upwards, 3 amperes is coming downwards. Okay, so that means these two you can combine, but you have to take the difference of the current. What is the difference now? Difference is 7 minus 3 is the difference. 7 minus 3 is 4 amps. Now the question is, 4 amps should be going upwards or 4 amps should be coming downwards is the question. Okay, so next we can combine these two also. This is a current source. Okay, we're not dealing with this resistance. Let resistance be there as it is. Since we are talking about the current sources in parallel, multiple current sources. Okay, we should keep this 10 ohms as it is. Let's not bother about this. What happens now? This is 7 minus 3 equal to 4 amps. Why? 7 is going upwards, 3 is going downwards. So that's why we have to take the difference. Now, where will be the direction of this current? Where will be the direction of 4 amperes? See, 4 amperes would be flowing in the direction of the dominant current. Which is the dominant current among the two? 7 amperes and 3 amperes. Which is the higher current? Which is greater current? Greater current is 7 amperes. So 4 amperes would be flowing in the direction of the greater current among the two. Everybody understand? So if you have multiple current sources in parallel, it can be reduced to one current source is what you have learned here. So therefore, just make a statement. Therefore, if multiple current sources are in parallel, then they can be combined to have one current source That's it. Therefore, if multiple current sources are in parallel, then they can be combined to have one current source. See, earlier we had 3 current sources. Now we have just one current source. We combine this 2 amperes, 3 amperes, 5 amperes to get 4 amperes. So when would do we add? The currents in the same direction are added. Okay. Then the currents in opposite directions are subtracted, and the resulting current would be flowing in the direction of the dominating current. That's it. Everybody is okay with this? Now, this is about multiple current sources. Okay, so this is our multiple current sources. Okay, when they are in parallel, mind you. Okay, when they are in parallel. Fine. Now, what to do if there are multiple voltage sources? Take down this, everybody. Second case is multiple voltage sources. Okay, in a series. Yeah. So if there are multiple current sources in series, okay, multiple voltage sources in series, what can we do is the question. Okay, so let's consider this. Here, let's have a resistor, right? Then you have a voltage source. You have another resistor. Then you have another voltage source. Okay, then you have, let's say, another voltage source like this. Okay, between the two terminals A and B, they're all series connections. Fine. Now a question, say this is 2 ohms and this is 3 ohms. How 2 and 3 are connected? They are connected in series. See, all the components here are connected in series. Okay, since these two are in series, we can combine these two to be 5 ohms. Let's do that later. Okay, so these two are in series, and as well these three voltage sources are in series, but they are of different polarities. Okay, so let's say this is 2 volts, fine, and say this is what, 3 volts, fine, and say this is 5 volts. So which two voltages are of same polarities there? Which two voltages are of same polarities there? See here, this 2 volts has plus sign first, this 5 volts has plus sign first. Okay, so this 2 and 5 needs to be added, and from that the 3 volt has to be subtracted. Okay, so let's do that. 2 and 3, since they are in series, the resistors, I'll make them as one resistor, that is 2 plus 3 equal to 5 ohms. Fine. Now I'm adding this. Okay, I'm keeping this as it is. What is this equal to now? This is 2 plus 5, because both are in same polarities. Both are of the same polarities. So this is 7 volts, and let's keep this 3 volts as it is between the terminals A and B. Is it okay with you? Now let's move on with this. This is A, 5 ohms. Fine. Now this is 7 minus 3, which is equal to 4 volts. We are doing 7 minus 3. 3 volts is having different polarity. 7 volts is having different polarity. Now resulting voltage should have which polarity? The resulting voltage should have the polarity of the dominant voltage between the two. That is 7 volts is greater voltage, right? So let's keep the polarity of that. So this is how I can deal with the multiple voltage sources in series. Okay, so you can make a statement if there are multiple voltages in series, so therefore multiple voltage sources in series can be combined into one voltage source. So when this reduction in number of voltages connected and current sources can be done, it can be reduced. So when current sources are in parallel, we can reduce that into one. If the voltage sources are in series, then we can reduce them into one. Get that?